Hey, gentlemen, why are we not prepared? Radical? Anyone? Anyone? X to the 1 over thing. X to the 1 over y? That sounds like super.
Y being the degree of the radical.
I heard 1 over a number. That's what I heard first. Then I heard x to the 1 over y.
Wait, x to the y is
X to the what?
y is
3?
z.
Oh, z. You guys are getting like really fancy schmancy. Y over z, z over y?
Y over z.
I put z over y.
Yeah.
Because it just like flows if I do z over y.
Where z is greater than y.
Does z have to be greater than y?
Well, not necessarily.
You're making up some things here, Tommy. Does z have to, first of all, I don't understand any of this. I don't understand any of it. I do, I'm just saying that. What is all this stuff? It's not a radical equation. There's no equal sign.
They're radicals.
They're radicals. What do you mean they're radicals? You still have not explained to me what a radical is.
A radical is one of those.
A root.
A root. A radical is a root. Very fancy. Can it be 1 over, well, first of all, those don't look like roots to me. Those look like fractions. I don't see how 1 over a number or 1 over y or z over y, I don't see how those are roots of any type. Elliot?
Well, isn't x x to the power of z over y equivalent to y root x to z?
Woohoo! Woohoo! Let's go back. X to the m over n. You did this with logs. You did this with logs. You changed to different forms, and then you raised to different powers, or you rewrote, 2 to the 3/4 as the 4th root of 2, or whatever. So, Elliot, can you tell me again, please, what you said?
That's equal to any root x over n, or x to the m.
Okay, so there's 2 ways. That's one way you can write it. So you can take the base x, raise it to a power, and then root the whole thing. What's my other option?
Quantity.
What's my other option?
Quantity and root x to the m.
Those are the same. Those are the same. Does it matter which one you do? Which one's better? No. Generally, you want to root first because this decreases the value of the base, and then you're raising it to a power, which is nicer than raising to some power. So, for example, let's say we have, I don't know. Let's say we have 2 to the 7/3, let's say. One way to do it is the cube root of 2 to the 7th. And you can figure it out, 2 to the 7th, right? 2, 4, 8, 16, 32, 64, 128. Remember your powers of 2 from last semester, we don't use count. So 2 to the 7th is 128. And then you would cube root that, which I don't know without my calculator. I don't know what it is. I don't care what it is right now. Or you could say the cube root of 2 to the 7th. Either way, you get the same answer. Either way, you get the same answer. Personally, if they were nice numbers, one second, Elliot, I would do this first. That's just, yeah.
Wait, for that equation, would a simplified form be like 2 squared times root 3, or 3 root 2?
You're saying 3 root 2. I think you mean the cube root of 2.
Oh, yes, that's fine.
Okay, so yes, let's just review that. 2 to the 7/3. So Tommy, I don't know if you had heard him, he said that, as long as, going back here, as long as z is less than y, if z is greater than y, that's a number more than 1. If z is greater than y, the number is greater than 1. So same thing here. So how can I rewrite 7/3?
2 squared.
Yeah, this is 2 squared times. I have that right? Is that right? What's 2 squared?
4.
And then what's the, how do I rewrite 2 to the 1/3? Cube root of 2. Do I know what the cube root of 2 is without my calculator? No, you might, but chances are you don't. So this is 4 times the cube root of 2. So that problem I just made up, that's the answer. 4 times the cube root of 2. None of these are equations. None of these are equations. So let's look, what's an equation? How do you distinguish an equation from an expression? An equal sign. Yeah, you're actually solving. There's an equal sign, you're actually solving. So if I ask you to solve the square root of x plus 3 equals, how about -5? Square root, that's a -5. How do you solve the square root of x plus 3 equals -5?
No solution.
No solution, that's a trick question. How do you square root a number and get a negative? You don't. You do not square root a number and get a negative. No solution. Or I can write that. What? I can write this?
No.
No! That does not mean no solution. That means empty set. You cannot write that. That was a trick here and a trick there. I know, I'm doing the double trickery today. How about the square root of 2x minus 3 is equal to 11? Can I solve that? I hope so, yeah. That is a radical equation. That is a radical equation. A square root is a radical. We're very used to, in your math life so far, you're very used to square root, but no, it's... Oh, I forgot we had a square root. Nothing. I was thinking the number was going to be super nice. I was thinking the answer was going to be 7, but I forgot about that whole squareable size thing. What do? I just told you. Squareable size. Kind of gave that away when I said squareable size. What happens when you square a square root? Don't use that word. What happens when you square a square root?
Reduces.
Reduce is the right word. It certainly doesn't do that other thing, but I think it simplifies. It simplifies down to 2x minus 3. It what? Oh, I thought you said something. Well, yeah, I think you did say something. You just don't want to repeat yourself. I'm skipping steps. What's x? 112? No?
62.
Add 3. Whatever. I don't know what I was thinking. I was thinking that 124 divided by 2 was not 64. Okay, moving on. What happens if you have something like, how about let's do the 4th root of 2x minus 3. I won't use 11. That would be a bit too high. How about 5? No calculator. No calculator. I know you want to. Five to the 4th comes from your log days, knowing your powers.
315.
What should I do? How do I start? Square both sides?
Fourth root.
Not fourth root.
Fourth power.
Raised to the fourth power. Right, we're somebody's saying square both sides, but you don't say, maybe we say cube both sides. Fourth both sides? Raised to the fourth power. Raise both sides to the fourth power. Is it wrong to say fourth both sides? No, I mean, like, we understand what we mean, but technically you should really say raised to the fourth power. All right, what do I get on the left?
2x minus
Equals,
625.
add 3, divide by 2, 314. Yeah? Check. You don't want to. Check. Plug in and check.
628, 625. Yeah,
Indeed it does.
Does it work? Yes? Okay. Sometimes they don't work. Sometimes they don't work. Let's do.
How do you read? Oh, you can. Wait, no, you can't. Oh, you can.
Wait a second.
It's negative.
Doesn't matter.
yeah, factors.
Check. Square both sides? No.
Add 4.
Yeah, you want to isolate the radical. Isolate the radical, so add 4.
That's what I thought after those why she did that.
You know what? You can talk about that later. What do I do?
Square both sides.
Square both sides.
Wait.
Hey, what happens when you square square root? Yeah. Not x squared plus 16. This is not x squared plus 16. You have to distribute out totally x squared plus 8x. Now what?
Oh,
Can't
wait.
factor it yet.
Subtract all the thingy.
Subtract all the thingy things.
Oh, yeah.
Bring like
All the way back.
Set it equal to 0. Subtract all the thingy things. How about we just make it equal to 0? It doesn't matter which side. Why are you going to make it equal to 0? What's the point? So you can factor and use the 0 product property. Yeah. All right, so we're going to get x squared plus 5x plus 6.
yeah,
Yeah.
6.
2 and 3. X equals -2. -3. Check. How many answers did you get? 2. which means the degree of the original problem was, no, it wasn't. You need to check. No, I mean, like, you need to check because the original, you got 2 answers, which means that the degree should have been 2. When you square both sides, when you cube both sides, when you raise both sides to the 4th power, whatever, you are changing the degree. Potentially creating extraneous, recognize that word? Extra. Okay, so you have to be careful. Don't be lazy. Check. You check one, I just circled it, I don't know why. They might not work. You check one, your neighbor checks the other. See what happens. If you don't have a neighbor, then
X plus 3.
I don't think so. Nine,
It's 4, right? 4.
so 2, minus
Two is equal to 2.
no. Yeah. Wait, yeah, that works. And then
We go to the negative, right? And then plus 10 has 1. We take 1. Oh, wait, no. Wait, no, I told you.
wait, what?
plug into the original equation to check.
Oh.
Plug into the original equation. So I see that a lot of you are doing it off the top of your head. That's fine. But just be careful because you make the mistake mentally and then all of a sudden the rest of it's wrong. Does negative 2 work? Does negative 3 work?
I did it to the first one.
Wait.
Oh.
Do you want me to show?
So how if they both?
Sometimes they both work. Sometimes when you change the degree, both work. Sometimes they don't. It totally depends on the problem. Pardon me?
Wait, but it had a degree of 1.
Correct.
So
And we altered it, hold on. It had a degree of 1. We altered it by squaring both sides and we made the degree 2. Both answers happen to work. There's no rhyme or reason. Both answers happen to work. Sometimes neither answer will work. Sometimes one will work. So let's try another one. Where you have to make sure you check. Let's do the square root of 22 minus 21x. No. How about 22 minus 12x? Plus 5. Yep. Very similar to the last problem. I already gave away the ending. I think I did.
No.
Because like the middle, oh wait, it's wait, no,
No, it's not. Cookies.
Oh.
You go to it.
Oh yeah, minus 1.
We need different squares?
Yes.
After this graph. This is not faster.
6 and 2.
6 and 2. Negative 2. What is that? What is that? It's like 3.
Oh. No, it's not supposed to work. Like 12.
Minus 2 is 3.
3 times 4, 12.
But you don't.
It's
What?
AC.
First step.
You have 2 here, right?
Subtract 5.
Subtract 5.
6x minus 2, right? 6 times 0 is not 3.
6 times 2 is 12.
I'm splitting the 20.
Gavin and Ami are having an argument up here about 6 times 2.
6 and 2?
No, I'm splitting the term.
Oh, he's doing splitting the middle term. He's factoring it different than you normally do.
Oh. You skip
But
that
either
step.
way, you should get the same answer. What do I do next?
What do you get in this?
Square.
Square both sides.
Like this. Are you factoring right?
What do you get on the left?
22.
22 minus 12x. Oh, I already see a shortcut to, oh no. What do you get on the right?
Minus 1.
Hello? What do you get on the right?
4x squared minus 20x.
Oh, okay, that makes sense. I thought you're thinking.
Are you sure? They should work.
No, I'm splitting the middle
That's
term.
what I'm saying.
Hold on, let me make sure. 22 minus 12x. Okay, fine, none of them work. What do you do?
I do need to choose.
No solution.
No! Okay, none of them work. I'm assuming you mean factoring. Nothing works.
No, the answer.
Oh, the answers, none of them work. I thought you were talking about like factoring it or whatever. Okay, so we get 0, 4x squared minus 8x. Help me out. Minus 3 plus 3? 12. 6 and 8? No. 6 and 2? Wow. Wow.
Middle term. You just went through.
6 and 2.
No, I was just trying to factor it out.
6 and 2. No, that's not right.
2x minus 1, 2x minus 2.
Oh my gosh. 2x minus 1. 2x minus 3. Thank you. Yes? So far. So far. Yes? Okay, 2 things. You can't be lazy. You can be lazy, but then you're going to risk getting the incorrect answer. They're fractions. I don't want to check.
Yeah, aren't
Oh,
they negative though?
wow. No, they're both positive. What I have is correct. What I have is correct. So you check 1/2, and that's not bad because 12 times 1/2 is 6. Excuse me. Excuse me. 2 times 1/2 is 1. I know that much. Plug in 3/2, blah, 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 blah. You need to check. The answer is neither of them work. That's the answer? No solution. Okay. The answer is no solution. Not neither of them work. So how did you get that neither of them work? You plug into the original equation and check. You have to plug in before you squared both sides. So this is a case where the degree was 1. Neither one of them works. Sorry, Elliot. Sorry, Elliot. I'm having a hard time speaking today. I can't multiply. I can't speak. All right, they get harder. Of course they do. But you can handle it. How about, oh, I like this one. Ready? Your teacher says I like this one. And you should. Exactly right. Star it. Remember my favorite log property? And did it not show up on just about everything? Yes. What are you talking about? What never showed up again? It was on the final. It was on one of your quizzes. It was on a test. My favorite. Brandon doesn't know my favorite property. Should we clue him in?
Yes.
What is it?
The log over.
Log
Log to the power.
It was like
Use
X
log.
log space X or something. I remember.
I
love that.
It's not that thing like
Is equal to whatever that is.
It's a Q.
I
That's a Q, Tommy. My handwriting is 1,000 times better than yours.
true, but
It's Q. You think his handwriting's better
no,
than mine?
it's not.
I just give me a hard time. I bet you sometimes it is and sometimes it isn't. It's very difficult to write on the whiteboard, so cut me some slack. How do I do this? Okay, wait, time out. No. You could, if you wanted to, square both sides now. When you square both sides, you're still gonna be left with a radical in the middle. But that's nice, but 4 squared is 16, yes? I could move, square both sides, still have a radical in the middle.
Oh, because
When you do the FOIL, the in between, 4 root x minus 4, 4 root x minus 4 is 8 root x minus 4. The x minus 4s do not just disappear.
wait, so we have to find like terms.
No, you have to make a decision. Make a decision.
Wait, why is there no? No.
There isn't either way. Okay, stop. Shh. You're confused on how to take care of the roots. I'm going to take out the x minus 4s plus 4s, and I'm just going to put roots. Root A plus root B equals, let's just say 4. Okay? When you square both sides, you get A plus 2 root AB plus B equals 16. There's still a root. Distribute. Root A plus root B times root A plus root B. Root A times root A is A. Root AB is 2 root AB. If you need to, write it out. So if we decide to square both sides, we're going to have roots. We move one of them and we square both sides, we are going to have roots. Lesser of two evils. They're both equally equal.
Considering that it's x plus 4 and x minus 4.
That's still an A and a B. No. When you multiply x plus square root of x plus 4 and the square root of x minus 4, the x's just don't disappear. Pick a side and we're going to show the whole thing rooting it out. Some of you I understand are confused. You need to write it out. Which way do you want to go? Square it right away, or do you want to move something right left? Don't care. You want to just square it?
No.
It doesn't matter, you guys. You're going to get double roots either way. Either way, you are going to have to square and then square. So, I heard Sid. He spoke the loudest. We're going to just square it as is. And if you don't want to do that, okay, move and square it. Oh, that doesn't erase very well.
Wait, we're gonna square it.
Write it out for yourself.
Then now we're just to the fourth.
Okay, here we go. Root x plus 4 plus root x minus 4 times root x plus 4 plus root x minus 4. I'm squaring it. I'm just writing it out, okay? If you want to do it in your head, feel free. Okay, so I took the binomial, multiplied by the binomial. So I just squared it, agreed? Did I just square it?
No.
Okay. 4 squared is 16. Okay. Root x plus 4 times, I'm distributing. FOIL, how you guys learned it. Root x plus 4 times root x plus 4 is x plus 4. Root 5 times root 5 is 5. Would you agree? Okay. Now, x plus 4, x minus 4 are not the same. X plus 4, x minus 4 are not the same. Do you agree with that?
Yes.
Okay, so I have root x plus 4, x minus 4. I have root x plus 4, x minus 4. So how many root x plus 4, x minus 4 do I have?
2.
Dos. So I have plus the square root of x plus 4. Oh, no, I forgot the 2. X plus 4, x. Okay, 2 of them. They're not the same, so you can't just magically to the square root side. They're not the same. I will maybe, we'll see. Elliot asked if we should multiply it out. I'm not sure yet, actually. Let me just see what else is going to happen here. And then you have root x minus 4 times root x minus 4, which is x minus 4. I may or may not, Elliot. Let's kind of see where it goes.
Does it matter much?
I think it will save us time actually if we don't, but I'm not sure. Legit, like I'm not sure.
Okay.
X plus X,
2x.
2X, awesome.
Yeah.
Oh, how cool is this? 4 minus 4, see ya. That's nice. And then I have plus, wait, did I do this right? Okay, plus, thank you, 2, X plus 4, X. I think, Elliot, I'm gonna have to do it one way or another.
Divide everything by 2.
Yes, yes, yes. What are you speaking over there, Jason?
Everything, you can factor out 2.
Yeah. You factor out the 2, you can divide by 2. Great, we just made the number smaller and that's super helpful. So I get X plus the square root of X plus 4, X minus 4 equals 8. What, am I done?
Both sides.
Yes, 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 yes. So, oh my gosh. Woohoo! So, here's what happens next.
Oh my god.
I feel like this big woo just went on.
You can just move the X and then you can square it.
Oh!
That's hard.
Okay, so I feel like half of you are at one place and half of you are at another place, and that's okay. Isolate the radical.
Yeah.
Isolate the radical. You don't want to square both sides here. Oh my goodness gracious, no.
Oh
If
my God.
if isolating the radical is an option, isolate the radical. Stop. Here, isolating the radical was not an option. I could not get root x plus 4 by itself or root x minus 4 by itself. I had no option but to do all this finagling. Here, if I subtract x from both sides, what happens? I'm subtracting x. Square both sides, go for it. I do believe you have to multiply it out. X plus 4 is minus 4. Yeah, I think you do. All right, I'm going to skip like 5 steps here. The left, I squared both sides, and I already multiplied it out. Okay. The right, I'm going to square both sides. So on the right, the square root sign disappears, and I'm going to FOIL that out right now. Oh, check that out, the x squared. See ya.
So does the 6. Wait, never mind.
Yeah. Look at those x squareds. Bye, 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 bye. Yes, Daddy. Woo! No woo. What did I just skip over? Because I'm too lazy to do it. Check. I've done the problem 8,000 times. No, I'm not going to check, but you should check. 8,000 is a slight exaggeration, but I bet you I've done that problem a few times in my life. Like 3, 4, 3. Your answer's fine.
1. Oh, it works.
Oh, it works.
3 plus 1 is 4.
3 plus 1 is 4. Excellent, Elliot. One more, and then we'll take a break. So it's got a rational, it's a radical equation mixed into a rational equation. What's it mean to be rational? Fractional form. You can write fractional form. And what's a radical? A root. So now you're going to have a fraction and a root. A radical within a fraction. Woo-hoo! Are you ready? Okay. I lost my spot. I don't think that's right. It's not. That's the problem number. But don't get mad. You should be doing your everything in pencil anyway. Ready for this? This problem is killer.
Oh wait, but it's the same denominator.
Oh, it's sort of the same denominator.
Oh no, it isn't.
I would. Jason says factor out a -1. Unfortunately, it doesn't help me. These are not opposites. Root x, negative root x. Positive 2, positive 2. No, but they're not opposites.
Oh, you can do it.
Are you making fun of me, Mira? Okay, yeah. Huh? What? You're like that. Okay, so when you were doing homework for today, I think, you know, those rational equations. So, side note. Yeah, you don't want to square it. Are you kidding me? Brandon says square both sides. I wouldn't do it either. There has to be an equal sign. If you had, okay, so like in your homework, whatever, you had 3 over x plus 2 plus 1 over x minus 3 equals, 10 over x squared minus x minus 6.
Find the common denominator.
Find the common denominator. This is what you did in the homework due today. Well, we could whine, or we could get better at it. Ella doesn't want to get better at it. Okay, common denominator. This looks horrible. I promise you, it is not horrible if you trust me. Trust me. What do you do here?
Multiply everything.
Multiply through by the common denominator. Correct?
Yes.
The common denominator there.
Yeah, there is.
There is, and it's not nearly as. You look at it, you're like, oh my God, there's square roots, there's subtraction. Well, that's exactly what you look like from my end of the deal. Okay. What is the common denominator? And I will give you a hint. It is not root x plus 2, 2 minus root x, x minus 4. It is not. If that were the common denominator, it would be pretty intense. Take a look. Figure out the common denominator.
Yeah, that's wait, no.
Times 2 plus root x.
What might you want to do first?
Factor out the 1.
Factor out the 1.
-1.
Okay, so, time out. Ami says factor out the -1. That's not going to help me too much because...
Aren't they the same though?
No.
Oh, yeah.
Okay. It's a good starting place. Unfortunately, it doesn't get me anywhere. Okay, you guys are a little like, this is the last one. I'll give you a break. You need to focus on this. Like, this is the honors part of math.
Factor out -1.
That's what I just did.
Oh, okay.
Jason says factor out the -1 like 3 minutes ago, and I said that's not going to help you. Ami says factor out a -1. Okay, let's try it. It doesn't get you anywhere. And now Jason wants to factor out a -1 again. You think that magically, like I did some voodoo on the board, and it's going to work? Ay, ay, ay. Let's figure the common denominator, please. X minus 4. X minus 4. How come?
Oh.
Because. root x
Oh,
plus 2 times 2 minus root x is x minus 4.
Ooh, okay.
You see something like this? No, really. Okay, guys, time out. You see a problem like that and you think, wow, that whole thing is the common denominator? That should be your first clue of I'm missing something, because that's a really intense common denominator. If I'm you and I'm doing the problem, I think, take a step back and see if maybe there's something else that you can do. So I'm going to multiply both sides by x minus 4. Do you see where the x minus 4 came from and why it works? Maybe you can look at it as this is A, this is B, that's A times B. That's essentially what just happened. I know, if it was the difference of, yes, difference of squares, yes. I've been known to make a mistake here or there. All right, so 2, the first fraction. What do I need to multiply the numerator by? Like, what doesn't reduce out? 2 minus root x.
what? Oh my god.
The 2, and then it's missing the 2 minus root x.
That's so sweet.
What goes here?
Mm.
Root x plus 2.
And so when you flip it, it becomes
Nope.
X plus 4.
Okay.
I got some.
Oh, I have the equation.
The common denominator is AB. Can't stop. The common denominator is AB. The first fraction has the A, it's missing the B. The second fraction has the B, it's missing the A. The third fraction on the right has A and B. See ya. Distribute, combine like terms, blah, blah. And let's hope it's no solution. I mean, let's hope it's not no solution.
How do you use x minus 4
without the negative.
without factoring in a -1 from 2 minus x?
Good. Oh,
Wait, what?
I think Jason's right.
We had to factor out the negative.
No, at the end we're going to. I think Jason's right. When you multiply this all out, you get negative x plus 4. I made a mistake. When you multiply this, you don't get x minus 4, you get 4 minus x. You get negative x plus 4, which is 4 minus x. Can't give up. You're never going to be able to do it. Where do I need a -1?
At the top.
So make that a positive. Make it plus.
Make what plus?
Instead of subtracting the two terms from each other, you'd rather add them. And you can do that by factoring out a -1.
Where does it go? Does it go in the first fraction, the second fraction, the third fraction, the whole?
Second fraction. So we were supposed to.
Well, yeah, you know what? You were 100% correct. I was wrong and made a mistake. Good job. Distribute, combine like terms, yada yada, solve.
Wait, that's all it?
Oh.
Plus it's plus X. That changes everything.
No, that's not true. That's not true.
What's going on?
On the right, we also need
No, I'm so confused. It's not very confusing. I just stopped doing it.
No, we're not gonna stop doing it. How'd, we said the x minus 4. I'm just gonna rewrite it, watch. This was root x plus 2 times 2 minus.
Wait, what? I just got.
What do you get when you multiply these together? What did we say it was?
Oh, 4 minus
4
x.
minus x.
I rewrote the original problem. 1 second, Jay. I took the original problem. This was the original problem. What's here in green? So I took the original problem and I took the x minus 4 and I changed it to 4 minus x and I factored out the negative 1, which I did not see. Yeah, Jay.
So in the original problem,
Yeah.
in the green, the step below that, should it be 2 times root x minus 2? Because you
Yes, and that's why, yeah. Yes.
Wait, so this is wrong?
That one? Yeah, because I think that if you want to go, I think, okay, here's what's happening. Half of you are like, I'm giving up, it's too hard. Where are these negative ones coming from? So I'm starting it over. Half of you are like, oh, I see it was a simple negative whatever mistake and are finishing that way. And that's fine. I'm starting sort of over because half of the people are like, I'm giving up, I don't know what's going on. Okay? So all I did was here, this becomes positive x minus 4 if I take out the negative. Okay, so now the only negative that I need to throw in so the first fraction, the 2, it needs to be multiplied by what? 2 minus x, or root x, which is what we had to begin with. Minus, the root x needs to be multiplied by what? Root x plus 2. And that needs to equal to, 4 minus x is reduced out, what are you left with? Negative x plus 4. Which some of you did a long time ago. Okay, distribute, combine like terms, blah, blah. What do you get? Some of you already done. No, it's not no solution. Is it really? No, it's not.
No.
What number is
No
this?
way.
Oh, it's no solution. Sorry.
Jason.
You've earned your break when I'm done. Oh, Jason. I'm going to tell you something in a minute. I'll tell you something in a minute.
So sad.
Oh wait, I got
Shut up. It's not-
Oh, I know
Add,
The x's can reduce.
right? The x's go. So you get 4 minus 4 root x equals negative 4. Subtract 4 and you get negative 8, yes?
Or you could
And then you can divide by negative 4.
Or divide by negative 4 now, it doesn't matter. Square both sides, divide by negative 4, blah, 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 blah. You get x is,
X equals
Oh, wait,
4.
no.
yeah.
subtract 4, you get negative 8. Divide by negative 4, you get 2. Square both sides, you get 4.
Wait a minute, you divide
I didn't do any dividing by 0.
Wait, but does
What are you talking about? We're not dividing by 0.
No.
If you plug it back in, you divide by 0.
You have to check, you have to check. You have to check. What happens when you check? Divided by 0. So it's no solution.
Isn't it undefined?
No, it's no solution. If it was just an expression, it'd be undefined. But because we're solving, it's no solution. The answer is no solution, not undefined. Undefined is when you have an expression and you're dividing by 0. Here it's an equation. So the answer is no solution. And then I have one, I promise, I get 30 seconds. Who was mad about no solution and how long the problem took? Okay. You're going to get to calculus class.
No.
Actually, next year. If you take trig honors, you're going to be in calculus class next year. And you're going to do problems that I promise you, for the most part, I don't think I lied to you. Maybe I've lied once or twice, but for the most part, I'm pretty straightforward. And you're going to do problems that take up the entire board, and the answer is going to be 0. And you're going to be like, oh my God, and it's so satisfying because you got 0. I'm just telling you that you better get used to it. I'm prepping you for this like massive letdown. Okay.
Thanks, I'm looking forward to
I know. You're going to need, you definitely need your calculator, and we're going to be doing all word problems. You're going to be like wishing for this with the word problems, right? 17, 18, 23.
Oh, I don't want to.
Oh, yo.